then the way that you would do this is you would, so that would be x. Our angle right here is 35. So we would say this is the opposite side, and 10 is the hypotenuse, and sine is opposite over hypotenuse. So we would say sine of 35 equals the opposite side, which is x, over the hypotenuse, which is 10. And then we would need to solve this for the x right there, so we'd need to get the x by itself, which means we would need to multiply both sides by 10. So I would get 10 sine 35 for our x, and your calculator is programmed with all of these good things here for the values of sine 35. So you'll have 10 sine 35, and you'll get 5.736. I just typed 10 sine 35 into the calculator. So I'm not going to walk through the notes exactly. What I want us to look at, I want to do a few pieces of the notes, but mostly I'm going to look at that unit circle picture, although I can't remember where I saved it at on here. I know we do it in pre-cal, but it might be in downloads. There it is. Why is it not coming up? Okay, here it goes. All right, so the unit circle is a circle that has a radius of 1. Okay? So what we're going to do is we're going to put angle measures on this circle, right? So for this circle, your initial ray would be right here. And so the terminal rays are shown going around. And we would go around counterclockwise. That's the positive direction. So this right here would be 0 degrees. This next angle that we have here is 30 degrees. Okay, so like this angle right here would be 30 degrees. The next one, actually let's do this. I, for right now, am going to skip. Let me change colors here. I'm going to skip this angle, this angle, this angle, and this angle. I am skipping those because they're not like the same width as the others, right? But if you pretend like those 4 lines were not there, then notice that like this angle is about the same size as this angle, and this angle, and this angle. They're all equal to each other, right? So if this is 0, 30, we're going to skip this one. What would the next one be? It would be a 30-degree angle if we went from here to here. But if we went from 0 to here, it would be 60. Okay? Then the next one would be 90. And we just keep adding 30, right? So the next one would be 120. Add 30 more. This would be 150. Add 30 more. This one's 180. We should know that one's 180 already because it's like halfway around the circle. then we would have 210, 240, put that down here, 270, 300, and 330. And if we want to, we could go back over here. This is also 360. You can call it 0 or 360. You probably used one of the 4 we were not supposed to use. Yes, I do. You should not have anything on these lines right here. These 4. Yeah, so 60 goes here. And then 150 goes here, 180 goes here, 210, 240 here, 270, 300, 330. You shouldn't have anything on those like little slices of pie. Yeah, you're welcome to highlight. If you want a highlighter, there's some up here. This angle right here would be 40. Actually, before we do those angles, let's do radians. Because we have to know this in degrees and in radians. So if you are using a pencil, you can write down what I'm about to write. If you're using a pen, I would wait till I fix it. Okay? Because I'm going to do this first the way I find it most logical, and then we're going to reduce. Okay? So this would also be 0 radians. Right here, right? 0 degrees, 0 radians. If I do radians for the 30-degree angle, it is pi over 6. Okay? So if you're using a pencil, it's okay to do this. But if you're using a pen, don't, because we're going to go back and fix it. So if that angle is pi over 6, that's the same as 30. Then I could just go around like I did with my degrees. So this would be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Okay, those are my radian equivalents. Okay, so we're just counting around. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. You do 12 pi over 6 if you want over here. I've ran out of room, so I'm not going to. All right, does that make sense how we're doing it? Okay, now, my Desmos looked funny whenever I pulled it up earlier, because Desmos will help you with this. So let me show you how, so you can check it, because I'm going to let you use this on the test that we take Tuesday. You cannot use it on the actual exam, because I can't give that to you. They'll fire me if I let you. To change your graph, it's really polar coordinates is what it is, but you don't learn about polar coordinates in this graph. It'll change it to where it looks like a unit circle. If you hit the wrench over here in the corner, then right here underneath grid, we have always kept it on this one right here. If you click on this one, it turns it to polar grid right here, which gives you 0, 30, 60, 90, 120, 150, and everything here. Okay, that is in degrees. Although I don't even know that we need it in degrees all that bad. The degrees are not the confusing part of this. The confusing part is the radians. So if you click the wrench right here, Notice down there at the bottom, you've got two options, radians and degrees. We've never changed it from degrees. Degrees is the default on the testing Desmos anyway. We've never changed it. But we need to change it today because we now know about radians. If you change it, notice it changed all this. But is that what I wrote down? Pi over 6 is, but then it's pi over 3, pi over 2, 2 pi over 3. 5 pi over 6 is the same. 7 pi over 6 is the same. What have they done? They just reduced the fractions. So let's go back to our unit circle and let's reduce the ones that will reduce. So pi over 6 does not reduce, it stays the same. 2 over 6 reduces to 1/3. So this one's going to be pi over 3. If you want to put them both, that's fine. Just know that, like, the pi over 3 is what they're going to give you on a quiz or a test or EOC. They won't ever give you 2 pi over 6. 3 pi over 6, 3 over 6 reduces to 1/2. So that's going to be 1 pi over 2, or it's usually just written as pi over 2. 4 over 6 reduces to 2/3. So that's going to be 2 pi over 3. 5 pi over 6 does not reduce. 6 pi over 6 reduces because the 6's just cancel out. So that one is going to be just pi, which we should know because 180 degrees is pi radians. That's what we use for converting, right? 7 over 6 does not reduce. 8 over 6 does reduce. That's going to be 4 pi over 3. 9 pi over 6 will reduce. That is going to be 3 pi over 2. And 10 pi over 6 will reduce. That is going to be 5 pi over 3. So double check your unit circle. If you're having trouble seeing it because it's too small up here, Google it. Google the unit circle and you'll see it. It'll bring it up. 12 pi over 6 would be 2 pi. Yeah, so if you wanted to put right here with this, this could be 0 or it could be 2 pi. Now, we skipped those 4 pieces right there that make you have these like little tiny slices of pie, right? So, halfway between 30 and 60 would be 45 degrees. So we want to add that. And the fraction that goes with that is pi over 4. Halfway between 120 and 150 is 135. The fraction that goes with this is 3 pi over 4. For halfway between 210 and 240, that's 225. And that one's going to be 5 pi over 4. And then down here for this last one, you'll have 330. Anybody think they know what goes there? It was pi over 4, 3 pi over 4, 5 pi over 4. 7 pi over 4. Your pi over 4s are odd numbers. And that you could count around the same. It's like pi over 4. This one's 2 pi over 4. Right here. Huh? Oh, yes, thank you. Good gracious. If you wrote down 330, like an idiot like I did, since it's already on there, change it to 315. If you blindly followed my poor advice. It is still 7 pi over 4. That is correct. So we have all of our angles filled in on the unit circle. Or we're working on filling in all of our angles on the unit circle. Double check. Because you are going to be able to use this on your test Tuesday next week. You also can use the back side of this paper like a note card. Okay, so you can use the back side of this paper like a note card. You won't be able to use your notes, but you can use the back side of it like a note card. Huh? Don't pack up. We're not done. All right. Huh? Tuesday. Yes. Okay. So, we need to fill in these coordinates on the outside. I should show you how to get them, but I don't have time. I will show you how to get these. The radius of the unit circle is 1. So that means, like, this is 1 on the x-axis. This is 1 on the y-axis. This is -1 on the x-axis. This is -1 on the y-axis. Okay? So right here, what are the coordinates of that point right there? They are 1, 0. Because your x-coordinate is 1, you go over 1, and you go up 0. Right? What are the coordinates of this point right here? 0, 1. Okay, just like you were graphing the point 0, 1 on the coordinate plane. What about over here? -1, 0. And what about down here? 0, -1. Okay? All right. I'm going to tell you what these are. I'd love to tell you why, but there's no time for it. This one is square root of 3 over 2, 1/2. Square root of 3 over 2. I'll zoom in to that first quadrant a little bit so it's bigger. I don't have time to tell you. I know how to explain it, but I can't. The why, probably not. Probably never. Unless you take pre-cal or come to Smart Breakfast. We're just out of time on it. The next one is square root of 2 over 2 and square root of 2 over 2. And then this one is 1/2 square root of 3 over 2. Okay? Now, in this quadrant, both coordinates are positive. In the second quadrant, your x is negative, your y is positive. These coordinates are the same over here, just their sign changes. So this one would be -1/2 square root of 3 over 2. This one matches up with the second one here. It would be negative square root of 2 over 2 and positive square root of 2 over 2. And then this one matches up negative square root of 3 over 2, positive 1/2. All right, we just got to get the bottom of it done. We're almost done. All right. So on the bottom, same thing is going to happen there. In the third quadrant, x and y coordinates are negative. So you're going to have right here negative square root of 3 over 2, negative 1/2. Right here you'll have negative square root of 2 over 2 and negative square root of 2 over 2. And right here you will have negative 1/2 negative square root of 3 over 2. No. And then last, this one's positive negative. So here you'll have positive 1/2 negative square root of 3 over 2. Here you'll have positive square root of 2 over 2 and negative square root of 2 over 2. And then positive square root of 3 over 2, negative 1/2. All right, so if you've got that filled in, you can go ahead and pack up. Tonight's homework is to do at least 5 problems from that practice EOC, okay? So that I passed out earlier. Make sure you have shown some work or given an explanation on your problems, okay? It can be any 5 problems, so I would pick the ones that are the easiest.
Mom giving me my phone.